Hello, everyone. I'm Tamas Kadlecsik, and today you've heard about different cloud technologies, but I would like to talk about the fact that sometimes you do need Kubernetes. So a little bit about myself. I'm a former developer and cloud ops engineer, now the CEO of RisingStack. And for the better half of the last 3 or 4 years, we've been helping companies to adopt cloud native technologies, or if they have already done so, to get the most mileage out of them. So let's talk a little bit about the Kubernetes itself. It's an open source container orchestration engine, has a vast ecosystem. So basically, if you run into any kind of problem, there's probably a library somewhere on the internet that already solves it. But it also has a daunting learning curve, and initially, it's pretty complex to manage. Now, if you come from a developer background, as I do, then cloud engineering itself and cloud ops, infrastructure engineering, is a complex and big topic. Basically, what Kubernetes does is not really masking away the complexity from you, but plunging you into deep water, because it merely gives you a unified control plane to handle all those moving parts that you need to care about in the cloud. So if you're just starting out right now, as I think Marku said before, then it's better to start with small things and not with the whole package straight away. So you want to decide if Kubernetes is for you. Now, what most people do, what I would do actually, initially, is read around on the internet, listen to blog posts, and these days you're going to find quite a lot of nice checklists that you can go through. So I compiled one for you here as well. First and foremost, Kubernetes is for you if you work with containers. Kind of speaks for itself for a container orchestration system. But you should also have more than one services or instances. Say you have a huge microservice architecture, or you have dedicated instances per tenant, having a lot of tenants as well. And you're also going to see on a lot of places that your services should be stateless, and your state should be stored in databases outside of the cluster. And we're going to talk about that a little bit later. Other key points or selling points of Kubernetes can be if you need fine-grained control over the network, and maybe the biggest selling point that you're going to see the first time you look into the topic is that it provides easy scalability. Okay, now let's take a look at the flip side of it. Kubernetes is not for you if you don't need scalability. And even though we're not present at the same space, but I hear a lot of you scoffing at me right now. But imagine there are a lot of products, a lot of companies around the world that where sales and registration is not as easy as that you just fill out the registration form and then you have a new user. But basically, it's pretty predetermined how many customers you're going to have. Sales can be done slower, so you have a lot of time to plan ahead for the resource usage you're going to have. Also, if your services rely heavily on disks, then you should think twice if you move to Kubernetes or not. Also, if you have a monolithic application that serves all your customers and you need some scaling here and there, then cloud service providers can handle it for you without the scaling groups. There's really no need to bring in the Leviathan Kubernetes for that. And also, if you don't host your infrastructure in the public cloud, then you probably should start smaller or look elsewhere. Now, I promised we're going to talk about disks and state. What is the problem with that? Basically, one disk can only be attached to a single node. So all the services need to reside on that one node, and thus you lose node autoscaling, which, as I mentioned, one of the biggest selling points of Kubernetes. With on-premises, the problem is similar. If you're on premises, then you need to buy the machines beforehand, and you can just conjure machines out of thin air, right? So basically, you also lose node autoscaling, unless, as it was also talked about before, unless you're willing to go hybrid cloud and bleed over some of your access usage by spinning up some machines and the public cloud. So I talked about bullet points, but maybe it's a little bit more tangible if we talk about an actual use case where we had to go through the decision-making process. So I would like to learn a little bit, talk a little bit about online learning platform, which is basically an application that you would imagine if you took your classroom and moved it to the internet. You can have conference calls, you can share files as handouts, you can have a whiteboard, and you can track the progress of your students. Now, this project started during the first run of the lockdowns in around March. So one thing that we needed to keep in mind is that time to market was essential. So we had to do everything very, very quickly. Of course, this product targets mostly schools, and schools around Europe especially. There are a lot of those, even if you think about, say, a German state or Polish voivodeship or what have you. So we're talking about millions of users from the point we go to the market. And it should also probably be run on premise, given GDPR and all the shenanigans. So, of course, initially we were provided with a proposed infrastructure where each school would have its own VMs, and all the services, all the databases would reside in those VMs. Now we're talking about thousands from the get-go that you have to build out within the matter of weeks. Well, handling that many virtual machines properly, handling rollouts to those, monitoring, all that kind of stuff, well, it sounded like a nightmare to begin with. So we were like, okay, maybe it's time to call the product people and talk to them about this proposed infrastructure. So yeah, hi guys, we would prefer to go with Kubernetes because handling stuff at that scale, we would need a unified control plane that Kubernetes gives us. And they were like, yeah, sure, go for it. And we were happy. But okay, just a couple of questions. Could we, by chance, host it in the public cloud? Well, no, forget about it. As I said before, governments tend to be squeamish about sending their data to the public cloud to US-based giants. Okay, anyways, we can figure something out, but do they use the file system heavily? Yeah, they definitely do. Okay, crap, what can we do? Well, all is not lost. Let's call the developers first, learn about the actual architecture of the system. And it's basically your usual microservice-based architecture where you have a lot of services talking about over HTTP and messaging queues. You have a lot of databases for each. And there was something that kept popping out, namely MiniO. We store that and that in MiniO. Now, if you haven't heard about it, MiniO is basically an object and file storage system that implements the S3 API. And we were like, okay, guys, but could we move all the files to MiniO? Yeah, sure, easy peasy. So we were happy again. Okay, but there was still another problem. So we had to call the hosting providers that would run in the countries. So, hi guys, do you provide hosted Kubernetes? Oh, well, at this scale, we can manage to do that. So we were happy again. And just to make sure, we wanted to run the numbers. So as I said, initially, we were targeting to be able to run 60,000 schools on the platform. So let's see, we shouldn't have more than 150,000 total pods. That's 10 pod per tenant, 60,000 tenants, we're good. We shouldn't have more than 300,000 total containers. It's one container per pod, so it's still 60,000 pods, we're good. It shouldn't have more than 100 pods per node and no more than 5,000 nodes. Hey, that's 60,000 pods over 100 pod per node. That's already 60,000 nodes, and that's just the initial rollout. So we're already over the 5,000 nodes limit. Okay, well, crap. But is there a solution to this? Sure, it's federation. We could federate our Kubernetes clusters and overcome these limitations. So, well, we worked before Federated, Promethei, and all that kind of stuff. So Kubernetes surely provides something for that, right? Well, yeah, it does, but there is a Federation v1 API which is strongly discouraged. But hey, Kubernetes Federation v2 is on the way. Yeah, well, it's still in alpha at the time when we were talking about this, but it's moving rapidly towards its beta release. Maybe it's going to come out in time. Oh, well, yeah, by that time it's been overdue by half a year, and being a short period of time while we had to pull this off, we really didn't want to live that much on the edge. So what can we do? We could federate by hand anyway. So what that means, as I mentioned earlier, with Prometheus, we can easily monitor all these, making it federated. We can handle logging as well easily. So to be honest, the only big problem is losing the unified control plane. Well, if we have 20 or so, it's still manageable, a lot more manageable than 6,000. So we needed to handle rollouts. And basically what we did is that the developer teams each already had their own GitLab repos and CI/CDs, so they could build their own Docker images and pull those to our GitOps repo, where we store our Helm charts. And upon pushing an image, we just roll the Kubernetes objects from these and roll those out to their respective cluster. And the idea was that we're going to use counties, provinces, voivodeships, or states as a way of logical separation. So within a country, each state or voivodeship or county would have its own cluster. So this way we can have like a key value store holding which cluster belongs where and which objects belongs in which cluster. The other thing we needed to solve was tenant generation, and that was also easy as well, because we just needed to create a CLI tool where you can set it up by providing the school's name, its county or voivodeship or what have you. That's going to designate its target cluster and then push it to our GitOps repo, and that basically triggers the same rollout as new versions. So we were almost good to go, but there was still one problem on premises. Now we managed to turn our hosting providers into some kind of public cloud or something we can think of as public clouds, but if you think about it, it's not only countries that want to educate their people, but also companies want to educate their employees. And if that company is, say, a bank, now they're just as squeamish about sending their data out to the public internet as governments, if not more. So we need to figure out a way how we could host this within a vault of servers completely separated from the public internet. Now, in that case, we have two main modes of operation. One is when a company just wants a boxed product, well, where they just want to have it installed. They don't really care about scaling it and whatnot. And the other one is where they expect it to be scaled, but they're prepared to handle this. In the second case, it's a kind of bring your own databases. So you can set up the system in a way that we're going to connect to your database. And in the other case, it's, well, what we could do is to package everything in one VM in one Kubernetes cluster. But I just told you like 20 minutes ago that you probably shouldn't use disks and shouldn't have databases within your cluster, right? However, in that case, we already had a working infrastructure. Kubernetes provided us with a kind of infrastructure as code already. So it only made sense to use that as a packaging tool as well, and use KubeSpray to just spray it to the server, to our target servers within vaults. And as I also mentioned, it's not a problem to have disks and DBs within our cluster, because the target here are companies that don't want to scale it anyway. So here it's not about scaling, it's mostly about packaging. Now, I also told you that you probably don't want to do this on premises. And this is right. If that's your main target, then you probably don't want to go with Kubernetes. However, as our main target was somewhat of a public cloud, it wouldn't have made sense to just recreate the whole thing, basically create a new product in a sense for these kinds of vaults. So as it is kind of a spin-off, it made sense here as well as a packaging solution. So basically, I've just given you a kind of bullet point list to help you determine whether Kubernetes is for you and or not. And then I just tore it apart and threw it into a basket. And the reason for this is that, as I also mentioned, CloudOps is difficult. There aren't really one-size-fits-all solutions. So basing your decision on checkpoints, checklists you see on the internet is definitely not a good idea. We've seen that a lot of times where companies adopt Kubernetes because it seems to fit, but when they actually start working with it, it turns out to be an overkill. So if you want to save yourself about a year or two headache, it's a lot better to first ask an expert, ask us, for example, and just spend a couple of hours or days with going through your use cases, discuss those, and save yourself that year of headache. Thank you for your attention.